Natural gas flows from a filter to the secondary pressure regulator mounted on the left side of the engine or mounted on the evaporator for the LPG engine. The secondary pressure regulator reduces the gas pressure to the pressure required by the fuel control valve. The LPG secondary regulator is housed together with the high pressure regulator. The B-Gas Plus, BGI, C+, and L+ engine's pressure regulator is a normally open spring-biased valve. With the valve open, gas flows past the seat and through the end of the valve. A small hole in the outlet side of the regulator allows inlet gas pressure to be applied to the diaphragm in the regulator. Pressure to open the valve is applied from the spring and fuel pressure on the back side of the valve. Pressure to close the valve is applied by incoming gas pressure on the diaphragm and the front side of the valve. As the pressures on each side of the valve vary, the valve moves, changing the flow area, thus regulating pressure. A vent slot in the cover allows the air movement necessary to allow the diaphragm to operate. As the diaphragm moves back and forth, air enters and exits the housing through this opening to prevent the air pressure from hindering the diaphragm movement. The natural gas travels from the regulators to the fuel shutoff valve mounted in the fuel block. The fuel shutoff valve is a 12-volt normally closed solenoid valve. A spring and inlet fuel pressure holds the valve in the closed position. When voltage is applied to the solenoid, it creates an electromagnetic force. When the magnetic force overcomes the spring and fuel pressure, the valve opens to permit gas flow. A Fleetguard natural gas spin-on filter is provided with each engine. The filter receives gaseous fuel from the vehicle fuel delivery system and removes oil vapor and contaminants 0.1 micron and larger from the natural gas. The filter must be drained daily to prevent the oil from passing through the system. After the natural gas flows past the fuel shutoff valve, it travels through a very fine mesh screen before continuing on to the gas mass flow sensor. The screen helps remove turbulence from the gas flow. The flow passage in the fuel block housing has a restriction that forces approximately 10% of the natural gas flow past the gas mass flow sensor wires. The gas mass flow sensor calculates the amount of natural gas flowing to the engine by measuring the cooling effect of the gas flow across two electrically heated wires. The sensor then sends a signal to the ECM proportional to the amount of gas flowing past it. The ECM uses this signal to make adjustments to gas flow into the engine. Gas flowing past the gas mass flow sensor wires rejoins the remainder of the gas flow. The sensor is a hot wire anemometer that measures the amount of power required to keep an electrically heated wire at a constant temperature. As more fuel flows over the wire, more power is required to maintain the constant temperature. The natural gas then flows to the fuel control valve. The ECM uses signals from the exhaust gas oxygen sensor and the gas mass flow sensor to determine the amount of fuel that should be sent to the engine and the amount this valve should be open. The fuel control valve is a normally closed, pulse-width modulated solenoid valve. When the fuel control valve receives a signal from the ECM, the solenoid pushes the valve off its seat and allows natural gas to flow into the mixer. The amount of flow is determined by the duty cycle of the ECM signal. The fuel control valve controls the ratio of the air-fuel mixture entering the engine by varying the amount of gas allowed to flow into the mixer. The fuel control valve is designed specifically for use with either LPG fuel or natural gas fuel and cannot be interchanged. This valve is on the low-pressure side of the fuel system and is not designed to flow a liquid. The mixer introduces the natural gas into the intake airflow. After passing through the mixer, the fuel and intake air are combined into an air-fuel mixture. The air-fuel mixture leaving the mixer is delivered to the throttle assembly, intake manifold, and cylinders of the engine. The mixer housing also provides the mounting location for the fuel control valve. Before removing any fuel system component, turn off the fuel supply at the vehicle's main gas shutoff valve. Start the engine and run it at idle until it runs out of fuel and dies. Drain the fuel filter. Clean the area around the filter head and remove the filter using a filter wrench. Clean the gasket surface of the fuel filter head. Lubricate the new filter seal with Lubriplate. Install the fuel filter on the filter head. Turn the filter until the gasket contacts the filter head surface. Tighten the filter an additional 1/2 to 3/4 of a turn, or as specified by the filter manufacturer. Turn on the vehicle's main shutoff valve and use a gas detector or a soap solution to check for leaks. On the LPG engine, check below the fitting or component. LPG is heavier than air and may not be detectable above the fitting. If leaks are found, shut off the fuel, turn off the key, and repair the leak immediately. If the engine is experiencing a fuel-related performance complaint, it may be due to oil contamination of the gas mass flow sensor. If the sensor cannot be cleaned, it may have to be replaced. Do not remove the screen from the gas mass flow sensor during cleaning. Clean the fuel control housing components using Cummins safety solvent and degreaser. Allow all parts to dry before installing. To prevent the gas mass flow sensor from being contaminated after reassembly, the entire air system should be checked for oil. If the oil is entering the air intake system from a leaking turbocharger seal or the crankcase ventilation system, the charge air cooler will need to be removed and flushed. Since oil contamination can also affect the operation of the oxygen sensor, the entire air system, including the throttle assembly and intake manifold, should also be inspected and cleaned. When servicing fuel components, replace all O-rings and rectangular seals. Apply a light coat of Lubriplate to all O-rings before assembly. With the ignition switch in the on position, but the engine not running, check for combustible gas at the rear cover vent hole. Use the gas detector for this test. If a leak is detected, replace the low-pressure regulator. Connect a pressure gauge with a 0 to 100 psi range to the CompuCheck fitting at the bottom of the low-pressure regulator housing. The fuel pressure can also be checked using Insight. Operate the engine at idle and then at the rated speed and full load. Measure the fuel pressure. If the pressure is not within the specified range, verify the fuel supply pressure from the high-pressure regulator using the procedure given in the service literature. An NPT port must be located on the catalyst assembly upstream of the core or in the pipe between the engine and catalyst. This port must be in an accessible location for back pressure measurements. If the catalyst core is visible through the outlet tube, a clamped outlet connection is required to allow for visible inspection of the core. If the core is not visible from the outlet tube, an inspection plug must be installed in an accessible location for catalyst inspection.